Welcome everybody. I hope that you are safe and healthy. Today, inshallah, I'll discuss Chemistry Chapter 10, Section 2, Solids, Part 1. Objectives. The objectives of our section is to describe the properties of solids according to the kinetic molecular theory. Distinguish between the two types of solids. Describe the different types of crystal symmetry and define crystal structure and unit cell. Let's dive in. The properties of solids. The first property of solids that the particles of a solid are more closely packed than those of liquids or gases. As you can see, the particles of solids are near to each other, more than that of liquids or gases. And the interparticle attractions. Interparticle attractions means the attraction between the particles. And the particles here means atoms, the attraction between atoms, or the attraction between the molecules of the solid is made up of molecules. So all interparticle attractions is stronger in solids than liquids than gases. The particles in a solid are held relatively in fixed positions. Why? Due to the strong attractive force between the particles. The particles attract each other strongly, so they do not move from their position. They only can vibrate around their positions. Solids are more ordered than liquids and much more ordered than gases. As you can see here, the particles of a solid are ordered more than liquids, more than gases. Definite shape and volume. Solids can maintain a definite shape without a container. Why? Due to the strong attractive forces. They keep a definite shape. Their shape doesn't change. Why? Due to the strong attractive forces. Solids also have definite volumes. The volume of a solid doesn't change, fixed, because the particles are packed closely together. And also the volume of a solid, it changes only slightly with a change in temperature or pressure. Types of solids. What are the types of solids? Solids can be classified to crystalline solids and amorphous solids or non-crystalline solids. So solids can be classified as crystalline solids or amorphous or non-crystalline solids. As you can see, what's the difference between the two types of solids? The crystalline solids and amorphous solids. Yes, great. Here, the crystalline solids, the particles are arranged in a certain pattern, takes a certain shape. While here in amorphous solids, the particles are not arranged. Most solids are crystalline solids, consist of crystals. And the crystal is the shape taken by the particles. Crystal, as you can see here, crystals. Why? This crystal takes this shape, and this one takes its own shape, and this is different from both of them, and so on. Why each crystal here takes a fixed shape? So, crystal is a substance in which the particles are arranged in an ordered geometric repeating pattern. This crystal takes its own shape because the particles inside it takes an ordered repeating pattern that gives the crystal its external shape, and so on. So a crystal is a substance like this in which the particles are arranged in an ordered geometric repeating pattern. While amorphous solid, a solid in which the particles are arranged randomly, as mentioned in the previous slide. The melting of solids. What's melting in general? Melting means the physical change of a solid into a liquid by addition of heat or addition of energy as heat. So this is a melting. To change from solid into a liquid. To change from solid into a liquid is called melting. And the melting point, it's the temperature at which a solid becomes a liquid. So the melting point, the temperature at which a solid becomes a liquid. Why? Why at this temperature a solid becomes a liquid? At this temperature, the kinetic energy of the particles within the solid overcome the attractive force holding them together. So, overcome the attractive force, they can change into a liquid, and the attraction force between particles decrease. Pay attention here that amorphous solids have no definite melting point. Crystalline solids have definite melting point, while amorphous solids have no definite melting point. Can melt in a range of temperature, not a certain or a fixed temperature. Examples of amorphous solids like glass and plastics. Glass and plastics are amorphous solids because the particles do not take a fixed pattern. Amorphous solids sometimes are called supercooled liquids. Supercooled liquids. What are supercooled liquids? They retain liquid properties. They keep certain liquid properties even at temperature that appear to be solids. They appear to be solids, but they have some properties of liquids. They can flow, but with a very low rate. These are called supercooled liquids. So glass and the plastics are supercooled liquids because they are amorphous solids, and amorphous solids are called supercooled liquids. Why? These properties exist in amorphous solids because the particles in amorphous solids are arranged randomly, not in a fixed pattern or fixed shape. Solids are characterized by the high density and incompressibility. We know that the particles of a solid are closely packed together, so no more spaces, and they have high density. They are most dense in solid state than in other state. Solids have higher density. Why? Why the densities of solids are higher, are larger? Because the particles of a solid are more closely packed than those of a liquid or a gas. As the particles are closely packed, so they are more denser than liquids and gases. And solids can be considered to be incompressible. Solids are incompressible, cannot be compressed due to the very small intermolecular distances between the particles. The last point to discuss today is the low rate of diffusion. Solids can diffuse, means can mix with each other. For example, here is a plate of copper and a plate of zinc. Copper and zinc. After a certain time, some atoms of copper start to diffuse in zinc, and some atoms of zinc diffuse in copper. They can diffuse with each other, can mix with each other, but they have low rate of diffusion, and the rate of diffusion is millions of times slower than liquids. So solids can diffuse, but their diffusion is very slow, very slow. They are millions of times slower than liquids. Thanks a lot for listening to this lesson. Until we meet again in another lesson.